go over the agenda a little bit. I'm going to give a little bit of an introduction. Then we'll have the two speakers speak, each of those for 20 minutes. And then after that, we'll have the Q&A panel where the speakers will accept questions. And we'll also have their technology providers join the panel in case there is some specific questions around the technologies that can be answered. So next, I'm going to go into my little introduction to kind of frame the discussion perhaps a little bit. And it'd be more specific around IoT adoption for OEMs. Our sense of IoT adoption is in two areas. One area is on the left side, the smart manufacturing. We see that in the process industries, mainly around predictive maintenance applications to prevent unplanned failures. In the discrete industries, we start to see it more around starting to emerge quality management type applications. And if you get into commercial buildings, it's energy management. We're not going to talk about that. Just to be clear, we're going to be talking about smart equipment, the post-sales after the equipment is available in the field, selling support services by the OEM, and this usually also is around predictive maintenance. Not always. We're going to hear the more thorough discussion of that from the speakers that follow me. Again, there will be preventing unplanned downtime. So I just would like to talk a little bit about the adoption of IoT by OEMs just for a moment, and the patterns that we've seen. I like to refer to this curve that Jeffrey Moore came up with, Inside the Tornado, a very popular book in the late 90s. It still applies today. And what he does is he talks about the willingness of an end user to adopt a new technology and the profile of the people who adopt it. So he has categories: innovators, early adopters, et cetera. And the real growth spurt occurs in that early majority, the pragmatists, where they stop to adopt the technology based on other people using it and having success stories. All right. And here I'm using the value of the equipment as kind of an indicator of how complicated the piece of equipment is and how critical it is. And often there's more intelligence in the more expensive equipment, which means it makes it easier to do the IoT. And we found, the semiconductor industry has been doing this for decades, meaning that the OEM monitors the equipment and helps the end user in terms of preventing downtime, but in their case, they also get involved in operational performance. They were doing this back when it was called M2M. We noticed about 3 years ago that the suppliers of million-dollar pieces of equipment, and this is people like Caterpillar and John Deere, started to adopt IoT and offer aftermarket services. More recently, past couple of years, it's been the $100,000 pieces of equipment. And in our customer base, we have OEMs who make equipment as little as $10,000 who are adopting IoT and consulting with us on how to do that. This goes way beyond just designing the piece of equipment for IoT. Each one of these segments also have different distribution channels in terms of how you sell the equipment and how you offer the support services. So in the case of the semicon equipment, this is a service provided by the OEM themselves. As you get into $1 million equipment, then you're dealing with local dealers. So the OEM designs the equipment for it, but the service, aftermarket service, is actually provided by a local dealership. And you get into $10,000 pieces of equipment, you start dealing with a retail channel. So on the surface, this may look like a technology adoption, but it also permeates into distribution channels and becomes a much more complex business problem, an agreement with channel partners. All right. So in this obviously we talk to a lot of end users and a lot of OEMs about how they're adopting this technology. And this is kind of the, I don't know, what we see as the recommended maturity chart for adopting IoT by OEMs. So on the bottom left, most of the pieces of equipment are already intelligent, meaning that they already have a computer inside it. Take like your cars. Your cars have, nowadays, new cars, hundreds of computers inside it. So the difference now is make it connected. How do I add either a Wi-Fi or a cellular network to the piece of equipment? Then the next step is to start testing that infrastructure that it actually works for the data collection. And we call it closed loop PLM. In most OEMs prior to IoT adoption, the only way they had to test the design of their equipment is they would have a test stand in development, a few pieces of equipment, and they run it through its paces. Now with IoT, it's the first time they have been able to get live operating data in the field and use that to improve the design of their equipment. All right? And this has the benefit of testing the infrastructure to make sure that the data acquisition is accurate, data is valid, and that improving the design of the equipment helps improve the blue here, meaning they improve the design of the equipment, they gain a competitive advantage, they take market share from other suppliers, and they grow the blue side. All right. The next step, and this could be, we have customers who was only a 9-month delay from the closed loop PLM. The next step is to start offering aftermarket services where you are selling maybe alert management so that when things start to go bad, the condition of the equipment starts to go bad, you send an alert to the end user. And some have extended this to actually have a service technician show up and do the repair prior to failure. And of course, that changes that business from basically spare parts, break fix, emergency repair, and grows it to a continuous aftermarket services type of business. All right. And digital transformation on the top there is when the OEM, and the poster child for this is really John Deere. They looked at the business processes of a farmer and developed software applications to help them improve their workflows. Really aligned with the equipment that they sell, but it is sold independent of the equipment. All right, it's a whole new business for them. An equipment provider becomes a software application provider, cloud software as a service. And the key point I want to make here for the users I'll learn how to use the mouse in a second, is I want to point out that an OEM who's adopted a competent IoT strategy is taking market share from somebody else. And they are also offering aftermarket services that you may want as an end user. So we, for a couple of years, have been recommending to our end user community that you make a viable IoT strategy part of your selection strategy, because you want to be on the winning side of this. This is going to be a market discontinuity with IoT, and there will be winners and losers. You really want to be with the winner in terms of growing the blue side, and you also may want to use some of those services to improve your own maintenance strategy, improve your own maintenance execution and costs. All right. Now here, I'm taking a little bit of a different tactic. I'm describing the scenario. Early in my career, I ran a maintenance department and had equipment suppliers that I deal with. This obviously was way before IoT and M2M, all right? So what I'm going to describe is, at the beginning here, why people have on-site maintenance groups. If I had a problem with a piece of equipment and decided to outsource maintenance to the OEM, the first thing I would do when the equipment went down is I'd call the OEM, tell them I have a problem. The odds are they would send somebody to look at it, and if it got complicated at all, what they would have to do is schedule another visit, because the first visit was really an inspection, and the second visit would bring the right spare parts and the right skills, right? And the OEM on the bottom there would have to have all kinds of inventory to respond to in various depots to respond to emergency repairs. So you'd have the problem occurrence, inspection, repair. This could be a couple of 3 weeks. Me as a maintenance manager, I would not survive if that was my strategy, because my company couldn't afford to have a piece of equipment down, not making product, losing revenue. All right. So this approach is the primary reason people have an on-site maintenance team, because they can't OEM it or can't contract it with the OEM. Now I'm going to take us to the scenario with IoT. So today, the equipment monitors its own health. It sends an alert via the web to a call center. Via the web, the call center can assess the health of the equipment. And when they send somebody out to do the repair, they already have the right skills and the spare parts, all right? And our research has shown that most OEMs, 30% of the time, they can make the repair via the web by changing some parameters or restarting, or maybe have somebody local do something very simple directed by the call center. The 80% really gets to packaging equipment, where you have mini stops, and there's some unique attributes to packaging equipment that allow that, all right? And the OEM can have lower inventory because the problem is identified well before the failure actually occurs. So they have time to schedule it and ship parts. So we have a situation here where the repair is made during a planned downtime and the problem is prevented. So you can now afford, as an end user, to outsource your maintenance to the OEM. And there's another subtlety here that I'll make from the viewpoint of the OEM, is when you know the condition of the equipment better than the end user, and you can make a repair before it actually causes them a problem, customer satisfaction goes way up. When I was in charge of maintenance and I had repetitive problems with a piece of equipment, the next time I needed to buy a piece of equipment like that, the odds are I did not buy it from that OEM. This completely changes that, all right? You have a much more repeat sign because you have this near zero unplanned downtime that you can not only promise, but you can actually execute on. All right. Oh, there's the lower left-hand corner. First time fix rate also goes up, way up, because you've been able to assess. That has been proven with elevator manufacturers anyway, as an example. All right. I'm going to talk about this in a little more detail in the 2 o'clock session around field service management. But I want to point out that you have the Internet of Things equipment, communications up to a cloud application typically, and then alert goes to a call center. Well, in the case of an OEM, this can take 2 forms. One is the alert, you make a call, you assess the alert, and you make a call to the end user, and their maintenance technicians take a look at it and make the repair. So it's a kind of a heads up to the on-site maintenance team. Or there's a whole business process you would have around engaging with a local dealer to do the repair. All right. So those are kind of 2 paths for the business process to execute the repair and prevent the unplanned downtime. All right. Now, this is also starting to transition to end computing. This architecture that I showed in the previous slide, when you have 100 pieces of equipment, certainly you can send everything up to the internet, but through the internet and into the cloud. But you have a network on the end, and we're in manufacturing sites where the Wi-Fi may not be as robust as we would hope or need. The IT organization occasionally there can be interruptions with the connection to the internet. And if somebody in marketing sends a 30 megabyte file to somebody via the internet, that can cause some interruptions to the flow rate. So these edge computing issues with the network, outage, latency, bandwidth, throughput, you may want to do some processing on the edge. And we're seeing that starting to be an adoption that occurs where there is some capability to do some pre-processing on the edge, certainly some storage of the data, and then sending it when the network is more robust and the bandwidth is available. So we're starting to see broad adoption of edge computing, of course, starting with the more expensive equipment and then migrating down to the less expensive equipment, just like that technology adoption curve that I showed previously. All right, and this slide is here to talk about the improvements in KPIs. We see mean time between failure, because now here I'm defining a failure as unplanned downtime, all right? You're being able to catch the problem, repair it before it causes unplanned downtime, and mean time between failure hopefully goes up to near infinity. Mean time of repair, this has two aspects for it. One aspect of course, is the first visit, you know what the problem is, you can make the repair. The other aspect of it is this cascading of a problem. And I'll talk about a gearbox, for example. One gear may start to have a problem, all right? And if you don't, and start to vibrate, and if you don't catch that, the teeth will start falling out and get into the other gears. So one small problem cascades into a huge problem, destroying all the gears in the gearbox. With your car, it's a similar thing. If the oil level's too level, the oil light goes on your dashboard. If that didn't happen and your oil got too low, eventually your engine would seize. So a $25 oil level problem becomes a $5,000 engine replacement problem. So the mean time to repair includes that kind of stuff, where you're catching the problem early when it's a small problem and easy to repair. And of course, that also affects your cost of maintenance too. And then the first time fix rate goes up because of the remote monitoring. And we also find that you're able to replace preventative maintenance, where you're kind of like changing the oil every 5,000 miles, with predictive maintenance, where you do the maintenance when it's really needed, not when you're kind of anticipating it, all right? So all the key metrics for your maintenance department become improved with industrial IoT and remote monitoring and predictive maintenance, analytics too.